Hi all, today we discuss more on the coordinates of a vector. First we consider R2, this is our R2. If this is our R2, we consider an arbitrary vector, say I'll write it as alpha, this is our alpha, alpha is equal to, I write this is a 3e1 plus 4e2, where e1 and e2 are standard bases. e1 is equal to 1 0 and e2 is equal to 0 1. So I draw the vectors e1 and e2. Here this is our uh, e1 and this is our e2. Okay, these are the two vectors e1 and e2. This is e1 and this is our e2. So we can write this alpha as a this vector alpha as a uh, 3 times e1 plus 4 times e2. Okay, so this is because if we take 3 times e1 here and 4 times e2 here, you can get this one. Okay, now we know that there are many other bases for this R2 other than this e1 and e2. Okay, now we choose another set of bases, say e1 prime. E1 prime is defined as I write it as uh, 2 comma 1, and I'll write e2 prime. E2 prime is minus 2 comma 4. So I mark this these two vectors here. One is 2 1, that comes from this. We have 2 here. This is our 2 1, and we have e2 prime as minus 2 4. That is minus 2 4. This is our minus 2 4. This is another set of basis vectors. Then I'll write this is e2 prime, and this is our e1 prime. When we write this is alpha, alpha is equal to 3e1 plus 4e2, we represent the coordinates of this alpha with respect to e1 and e2 is 3 comma 4. Okay, this is the definition of the coordinate. Okay, if you write this is our b is equal to e1 comma e2 is a basis of standard ordered base of e1 basis vectors consisting of e1 and e2, and I call it as b prime as some e1 prime and e2 prime. That's another set of vectors which form another set of bases. Okay, so if we write alpha is equal to 3e1 plus 4e2, we write 3 4 is the coordinates of this alpha with respect to b. Okay, how do you get the coordinates of this alpha with respect to uh, b prime? This is our intention. So if we change bases, then the coordinate will change. So in order to get this, we need to say that this this alpha, we need to write this alpha like this. This is our perpendicular, and we need to get the perpendicular to this side as well. Okay, if we got these 2 points, these two length, not point, these two length, we can say that if we find these two length, we can say that this times e1 prime plus this times e2 prime is the alpha. Then you can easily find out the coordinates, say a and b, from those. Okay, so in order to get this, if this is alpha, you know that alpha, this is the shadow of this vector to e1 prime. Okay, then in order to get this and this length, what we have to do is, first we need to set the unit vector along this direction. e1 prime, and we need to multiply with this length. Okay. Similarly, we need to get unit vector along this direction, that is obtained by e2 prime divided by mod e2 prime, and we need to multiply it with this length, that is these two vectors. If you got these two vectors, we can easily write this alpha in terms of e1 and e2. So in order to get the this vector, we write what is this length. This length is the shadow of this, or projection of this alpha, projection of alpha to this e1 prime divided by uh, no e1 or modulus e1 prime times the unit vector. This is the this length, and in that times the unit vector along that direction. Okay, so e1 prime, this is the unit vector along this direction. This will give this vector. Okay, so this is nothing but alpha is 3 e1 plus 4 e2 dot e1 prime. E1 prime is this one, 2 comma 1, and whole divided by norm of e1 prime into norm of e1 prime here, or modulus of e1 prime, modulus of e1 prime square. So modulus of the e1 prime, even the modulus of e1 prime is obtained from this itself, that is root of 2 square plus 1, that is equal to 5 root 5, then square is 5, so we have 5 here, times e1 prime. So this is equal to when you write 3 times e1 4 times e2, that is 3 comma 4, 3 comma 4 dot 2 comma 1. Okay, 3 comma 4 dot 2 comma 1 divided by 5 times e1 prime. This is the this vector, and you can write it as this is 6 plus 4, 10 by 2, 10 by 5, that is e1 prime, that is equal to 2 e1 prime, that is this vector. Now you can, similarly you can find alpha dot e2 prime divided by modulus of e2 prime. This is the orthogonal projection of this vector alpha to e2 prime, and we need to multiply it with e2 prime unit vector along that direction, e2 prime divided by modulus of e2 prime. So this is obtained by alpha dot e2 prime, that is 3 comma 4 dot e2 prime. What is e2 prime? E2 prime is minus 2 comma 4 divided by modulus of e2 prime. Modulus of e2 prime is obtained from here, e2 prime square root of 4 plus 4 4 plus 16, that is equal to 20 root 20. So we can get that is 20, square of that is 20 times e2 prime, that is equal to when you take the dot product of this, we are minus 6 and 16, so 10 by we have 20 e2 prime, that is equal to 1 by 2 times e1 prime, e2 prime. So this alpha can be written as in terms of e1 prime and e2 prime. You can write it as 2 times e1 prime plus 1 by 2 times e2 prime. So this will give the coordinate of alpha with respect to b prime, which is equal to 2 comma half. 2 half. Okay, this is the coordinate of alpha with respect to b prime. Now here we have the coordinate of alpha with respect to b, that is this one, and coordinate of alpha with respect to uh, this is coordinate of alpha with respect to b, and this is coordinate of alpha with respect to b prime. So for any vector, now when any vector alpha belongs to R2 or any vector space, we can get the coordinates of alpha with respect to bases. Okay, if b and b prime are two bases, so we can get b and b prime are the bases, then alpha with respect relative to b and alpha relative to b prime are the coordinates. So these need not be the same. If basis changes, this will be 3 comma 4, and this is 2 and half. Okay, these are the coordinates, different coordinates for a same element alpha belongs to R2. Okay, now if we are given an alpha belongs to R2, then different bases B and B prime, then you can connect these two with a matrix. You can easily find a matrix P such that P into this is equal to this one. Okay, this is the idea here. These two uh, coordinates can be connected through a matrix called P. So you can easily find a P such that coordinate of alpha with respect to B is equal to coordinate of alpha with respect to B prime. So P times coordinate of alpha with respect to B prime. This is the next theorem. For any alpha belongs to this R2, this not even R2, this is for any vector space V. We are given two different bases, then there is two different coordinates corresponding to a single alpha, and that coordinates can be connected through a matrix called P. So P into this is not only a matrix, it is a non-singular matrix. Okay, non-singular matrix. Here we find a matrix in such a way that the coordinate of this alpha with respect to B is 3, 4, and coordinate of alpha with respect to B prime is 2 half. This is the matrix we called 2, 1, and 2 half, minus 2, 4. This is that matrix. This is what we called P. How do you get this P? This P is obtained by choosing two vectors E1 prime and E2 prime, and write E1 prime as E1 prime is 2 comma 1, and write this E1 prime as 2 times 1 0 plus 1 times 0 1. So this is the linear combination of this E1 prime in terms of E1 and E2. Okay, similarly, if you take E2 prime, that is nothing but minus 2 comma 4, that is equal to minus 2 times E1, that is 1 0, plus 4 times E2. So using these coefficient, I constructed this P. Okay, what is P? P is 2 comma 1, that is obtained from this coefficients, and this minus 2 comma 4, the next column is obtained by taking this coefficients. Okay, that is the these are the coordinates of these two. One is the matrix 2 1 is the coordinates of E1 prime relative to this E1 E2. Similarly, 2 minus 2 4 is the coordinates of E2 prime corresponding to the basis E1 E2. So this is the next theorem. If you are given any alpha belongs to B and two different bases B and B prime, then you can connect the coordinates of alpha relative to the basis B and coordinate of alpha relative to the basis B prime using a matrix P, and this matrix is always a non-singular matrix. If you change this alpha as beta, then you can write the same relation without changing this P. So this P is independent of this beta and that vector alpha or beta. Okay, so this B depends only on this B and B prime. That is our next theorem. So next theorem we will discuss tomorrow. That is the general case of this what we have discussed here.